uh, client program in Java remote method invocation. Here now we are focusing on client program. A typical client program obtains a remote reference to one or more remote objects on a server and then invokes methods on them. Here you can see a Java RMI architecture in a different diagram. Java remote method invocation RMI allows the distribution of Java objects, enabling clients to invoke methods on remote objects. Here in step 1, a server exposes a remote object by exporting its client stub to the RMI registry. In step 2, clients use the registry to look up exported objects and receive their stub. Step 3 here, if the client JVM does not find the class definition of the remote objects interface or any other types that are used within the interface in its local class path, it queries the code base whose location can be provided within the stub by the remote object server. Step 4, client can use the client can then invoke methods on the remote server objects. The standard RMI registry requires the remote server object and the RMI registry to be collocated on the same machine. For clients to be able to contact the registry, this machine must be publicly reachable. The same applies to the code base, which must reside on a publicly reachable HTTP server. I repeat the process. Here the server registers the remote object, step 1, and in step 2, the client looks up the stub in the registry. And step 3, the client requests the stub class file here, and the client invokes method on the remote object, and the remote object and the registry have to reside on the same machine. Here you can see a remote object, registry, code base, and client. Here remote object rebind registry, and here client looks up registry and stub is returned from registry to client, and clients get code base and class is returned from code base to client. Client invokes remote object and results are returned from client to remote objects to client. Here we are considering how do Java RMI clients contact remote Java RMI servers. For an RMI client to contact a remote Java RMI server, the client must first hold the reference to the server. The naming.lookup method call is the most common mechanism by which client initially obtain references to the remote servers. Remote references may be obtained by other means. For example, all remote method calls can return remote references. This is what naming.lookup does. It uses a well-known stub to make a remote method call to the RMI registry, which send back the remote reference to the object requested by the lookup method. Every remote reference contains a server hostname and port number, which allows client to relocate the VM that is serving a particular remote object. Once a Java RMI client has a remote reference, the client will use the hostname and port provided in the reference to open a socket connection to the remote server. Please note that with Java RMI, the terms client and server can refer to the same program. A Java program that acts as a client RMI server contains exported remote object. A Java RMI client is a program that invokes one or more methods on a remote object in other virtual machine. If a VM performs both of these functions, it may be referred to as an RMI client and a Java RMI server. Here you can see a RMI client, and here you can see RMI registry. Here my interface mi and mi equal my interface naming.lookup the server / object to get. Naming lookup is inside RMI client, and step 2, create new instance of well-known stub class for the RMI registry running on the server. Step 2, call lookup object to get on the registry using the reference created in step 2, and this is connected to RMI registry. And registry return, step 4, the registry returns a remote reference to object to get. And step 5 is from naming.lookup. Naming.lookup returns the remote reference to object to get to the RMI client. Here you can see an RMI distributed applications that uses the RMI registry to obtain a reference to a remote object. RMI application often comprise two separate programs, a server and a client. A typical server program creates some remote objects, makes reference to these objects accessible, and waits for client to invoke methods on these objects. A typical client program obtains a remote reference to one or more remote objects on a server and then invokes method on them. RMI provide mechanism by which the server and the client communicate and pass information back and forth. Such application sometimes referred as a distributed object application. Distributed object applications need to do the following. Locate remote objects. Application can use various mechanisms to obtain references to remote objects. For example, an application can register its remote objects with RMI simple naming facility, the RMI registry. Alternatively, an application can pass and return remote object references as a part of remote invocations. Communicate with remote objects. Details of communication between remote objects are handled by RMI. To the programmer, remote communications look similar to regular Java method invocations. Load class definitions for objects that are passed around. Because RMI enables object to be passed back and forth, it provides mechanism for loading and object class definitions as well as for transforming an object's data. This diagram this illustration depicts an RMI distributed application that uses RMI registry to obtain a reference to a remote object. The server calls the registry to associate or bind a name with a remote object. The clients looks up the remote object by its name in the server's registry and then invokes a method on it. This illustration also shows that the RMI system uses an existing web server to load class definitions from server to client and from client to server for object when needed. Here RMI client is connected to RMI registry. So RMI is passed from RMI client to RMI registry. RMI client is connected to RMI server. RMI is passed from RMI client to RMI server, and RMI server is connected to RMI registry, and RMI is passed from RMI server to RMI registry. RMI registry is connected to remote server. URL protocol is passed from RMI registry remote web server. And RMI client is connected to web server, and URL protocol is passed from RMI client to web server. RMI server is connected to web server. URL protocol is passed from RMI server to RMI web server. Here you can see a remote method invocation. Here the all method publish on server are registered on RMI registry like UDDI for web services. The client calls the local method stub to perform this operation. The stub on the client calls RMI registry to know whether that method exists. And correct way to call it. Client stub calls this method on the server skeleton. Calls this method on server. So skeleton receive this request and communicate with the software on the server. Then it receives the response and send this response to the client stub. Here you can see a client host here. And server host here. Server object interface, client skeleton, and server objects are in client server host. And here step 1, the server object registers server objects on RMI registry host. RMI registry is in RMI registry host. And step 2 here, look. Then here the server object interface, client program, and service stubs are in client host. This is client program. And here server client program looks for server objects in RMI registry host. RMI registry host return server stub here to client program. Client program interact with server stub. Server stub do the data communication between with service skeleton, and service skeleton interacts with server objects. And simply server objects register server object with RMI registry here, RMI registry host here, and client program looks for server object in RMI registry host, and RMI registry host return service stub to our client program, and data communication then occurs between server stub and server skeleton here. This is the another diagram for RMI architecture here. Java remote method invocation RMI, which is a simple and powerful network object transport mechanism, provides a way for Java program on one machine to communicate with objects residing on different address spaces. RMI is an implementation of the distributed object programming model comparable with COBA, but simpler and specialized to the Java language. The overview of RMI architecture is shown in this figure here. This is another figure to depict RMI architecture. The important parts of the RMI architecture are the stub class, the object serialization, and the server-side runtime system here. The stub class implements the remote interface and is responsible for marshalling and unmarshalling the data and managing the network connections to the server. An instance of a stub class is needed on each client. Local method invocations on stub class will be made whenever a client invokes a method on the remote objects. Java has general mechanism for converting objects into streams of bytes that can later be read back into an arbitrary JVM. This mechanism is called object serialization, is essential functionality needed by Java RMI implementation. It provides a standardized way to encode all information into a byte stream suitable for streaming to some type of network or a file system. In order to provide functionality to an object, must implement the serializable interface. A server-side runtime system is responsible for listening for invocation request on a suitable IP port and dispatching them to the proper remote object on the server. Since RMI is designed for a web-based client-server application over slow network, it is not clear it is suitable for high-performance distributed computing environment with low latency and high bandwidth. A better serialization would be needed since Java's current object serialization often take at least 25% and up to 50% of time needed for remote invocation. Here you can see client and client code and stub are inside the client, and you can see the server here. RMI runtime system and remote objects are inside server. Here client code calls stub method locally, and stub sends marshals arguments. RMI runtime system call remote object method locally to remote object, and remote object returns value or throw exception to RMI runtime system, and RMI runtime system sends marshaled result or exception to stub, and stub returns value or throw exception to client code. Here we are considering compile an example. These instructions assume development is in the Zelda home directory. The server program is compiled in the home directory for user Zelda, but copied to the public _HTML directory for user Zelda where it runs. Here is the command sequence for Unix and Win32 platforms, and explanations as follows. The first two JavaC commands compile remote server and send class and interface. And the third javac command compiles the RMI client 2. The last javac command compiles the RMI client 1. Next line runs the RMIC command on the remote server class. This command produces output class of the form class class name underscore stub.class and class name underscore scale.class. These output classes let client invokes method on the remote server object. First copy command moves the remote server class file with its associated scale and its stub class files to publicly accessible location on the home Zelda public underscore HTML classes directory, which is on the server machine. So they can publicly accessed and downloaded. They are placed in the public underscore HTML directory to be under the web server running on server machine, because these files are accessed by client program using URLs. The second copy command moves the send class file to the same location for same reason. RMI client 1 and RMI client 2 class files files are not made publicly accessible. They communicate from their client machines using URLs to access and download the remote object files in the public underscore HTML directory. The RMI client 1 is invoked from the client side directory that uses the client side web server, server side web server and client side Java VM to download the publicly accessible files. And RMI client 2 is invoked from the client side directory and uses the server side web server and client side Java VM to download the publicly accessible files. So here you can see remote client 1 is inside client host, client side Java VM, remote client 2 is in client host, client side Java VM here, and remote server object is in server host, the server side web server and Java VM. RMI client 1 RMI client 1 interacts with server host and RMI client 2 interacts with server host. Here you can see code segment to implement the client. The client program obtains a stuff for the registry on the server host, lookups the remote object stub by name in the registry, and then invokes say hello method on the remote object using stub. So here is the source code for the client. This client first obtain the stub for the registry by invoking the static locate registry dot get registry method with the host name specified on the command line. If no host name is provided or if no host name is specified, the null is used as the host name uh, indicating that the local host address should be used. Next, the client invokes the remote method lookup on the registry stub to obtain the stub for the remote object from the server's registry. Finally, the client invokes say hello method on the remote object stub, which causes the following actions to happen. Client-side runtime opens a connection to the server using host and port information in the remote object stub, and then serialize the call data. Server-side runtime accepts the incoming call, dispatches the call to the remote object, and serializes the result, the reply string, for example, saying hello world, to the client. And client-side runtime receives, deserializes, and returns the result to the caller. As an exception example, we can consider remote exception. If remote communication with the registry failed, if exception is a server exception containing an access exception, then the registry denies the caller access to perform this operation. This method, this exception can be occurred, for example, lookup string method in interface registry. As an example, too, we can consider this java.rmi property, java.rmi.server.codebase. This property specifies the locations from which classes that are published by this VM, for example, stub classes, custom classes that implement the declared return type of a remote method call, or interfaces used by a proxy or stub class may be downloaded. The value of this property is a string in URL format or a space separated list of URLs that will be the codebase annotation for all classes loaded from the class path of and subsequently marshaled by this VM. Note, this property must be set correctly in order to dynamically download classes and interfaces using Java remote method invocation, Java RMI. If this property is not set correctly, you will like to encounter exceptions when attempting to run your server or client. As an example 3, we can consider this. This is starting the client in Microsoft Windows. In this particular example, once the registry and the specific engine for this program are running, you can start the client specifying the following. The location where the client serves its classes here for by using the java.rmi.server.codebase property. The java.security.policy property, which is used to specify the security policy file that contains the permissions you intend to grant to various pieces of code, and as command line arguments, the host name of the server, so that the client knows where to locate the remote object, and the number of the host name, so that the client knows where to locate the remote object, and the number of decimal places in this particular example to calculate value of 5 in this particular example specifically. Note that the class path is set on the command line so that the interpreter can find the client classes and the jar file containing the interfaces. Also note that the value of java.rmi.server.codebase property, which specifies a directory hierarchy, ends with a trailing slash. Now we are considering the remote interface in client interface. In RMI, a remote interface is an interface that declares a set of methods that may be invoked from a remote Java virtual machine. Interface remote. The remote interface serves to identify interfaces whose methods may be invoked from a non-local virtual machine. Any object that is a remote object must directly or indirectly implement this interface. Only those methods specified in a remote interface, an interface that extend java.rmi.remote, are available remotely. This is in the package java.rmi, which is in the module java.rmi. Now we are considering exception example remote exception. The remote exception class remote exception. A remote exception is the common superclass for a number of communication related exceptions that may occur during the execution of a remote method call. Each method of a remote interface, an interface that extend java.rmi.remote, must list remote exception in its throws clause. This is in the package java.rmi, which is in the module java.rmi. Now we are considering the naming class. Class naming. The naming class provides method for storing and method obtaining references to remote objects in a remote object registry. Each method of the naming class takes as one of its argument a name that is a java.lang.string in a URL format without scheme component of the form //host :port/name, where the host is the host remote or local where the registry is located, Port is the port number on which the registry accepts calls, and where the name is a simple string and uninterpreted by the registry. Both host and the port are optional. If the host is omitted, the host default to the local host. If the port is omitted, then the port default to the 199, the well-known port that RMI registry uses. Now we are considering Java RMI implementation logging. The property name sun.rmi.client.log calls, the logo name sun.rmi.client.call. Information logged here, client-side remote calls and exceptions.